Hello, we are Group Lemonade. In this presentation, we'll briefly talk about our Pioneer Project report. Our group including Reggie Liu, Haoyang Qin, Elena Zhai, and me, Jin Min. First, let me go through our agenda. This presentation will briefly include project topic, expected goal, timeline, cost, the training process in Microsoft and Ctrain, as well as the proposed solutions and/or lessons learned. First, let me talk about the project. Upon the release of white papers or work reports from the central government, the local office will have to issue their usually bilingual as soon as possible. Tasks are usually challenging because linguists shall not only finish the job in a short time, but also strictly follow the style of a central government version, let alone the term, core concept, and leadership quotes. In this context, this project aims to train a machine translation engine using governmental documents, including official discourses, articles, white papers, and annual work reports. The engine is expected to recognize governmental terms and, most importantly, imitates the writing style of the predecessors' linguists so that it can mitigate the tension of high-volume workflow. Through certain adjustments in every round, the engine aims to meet PEMT standards with more accurate term use and more effective message conversion. First, let me talk about our expected goal. We expected the quality to be 100% professional and clean layout, accurate translation, acceptable score from evaluation based on PEMT. In timing, we expected the PEMT to be 40% faster than human translation. In pricing, our pricing goal is the PEMT approximately 15% savings over human translation. Here is our project timeline. Our project remains a month. It starts from the beginning of March until the beginning of April. The process including client kickoff meeting, file and datasets preparation, training design, training rounds, manual assessment and post-editing, as well as our finding and conclusion. Then I'm going to talk about our project cost. Our project cost including 4 parts. They are administrative cost, engineer cost, linguist cost, and management cost. The administrative cost including meetings and paperwork, we expect it to be 40 hours and $30 per hour, so the total will be $1,200. And our engineering cost including training, testing, and data cleaning, which is expected to be 30 hours and the total will be $900. And our linguist cost including linguistic quality tests, it estimated to be 20 hours and the total will be $600. Then it's our management cost, approximately 20% of the total cost. So our whole project total cost will be $3,240. Next, I'm going to pass to my colleague Elena to further talk about the training process.
Thank you, Jean, for passing it to me. So I'll be talking about our training process for Microsoft Custom Translator. So the first step is to identify datasets. Since the objective of this project is to train an effective MT engine that could ideally process large volumes of government pieces, paperwork translations from simplified Chinese to English, we first identified and gathered our tuning dataset, testing datasets, and training datasets. And the second step would be a TMX prep and cleaning. The first step is to train our MT module using Microsoft Translator. We prepared appropriate TMX files that are up to standard, and our TMX file come from a reliable source, which includes bilingual government speeches. For the past decade from Chinese to English, we performed the following cleanup steps for quicker and more efficient training, which include the first step is to remove duplicated segments in both source and target segments, and the second is to remove segments with over 150 characters, and lastly, we check for any empty segments and remove them. And the third step is to start training rounds. As we targeted improving the blue score of our MT engine for each round, we performed 5 rounds altogether with different configurations and combinations of the tuning, testing, and training datasets. And the results will be demonstrated to you in the next slides. And lastly, once we got our training result, we started to do data analysis from blue scores, MTPE versus human translations, as well as LQAs. I'll be passing on to my colleague Reggie to show you a detailed overview of these results.
Okay, thank you, Elena. Now I'm gonna analyze our Microsoft models. First, I'm gonna talk about the blue score results. As we can see from the charts, the baseline blue was 21.29, which was generated by the default Microsoft generic model. And in total, we took 7 rounds of training, including a test run and a parallel round, which I will talk about later. The highest blue was in round 4, 25.21, and the average blue score of the 7 rounds is around just 21.51, which was quite low but was not unexpected. And after all these rounds of training, we took a sample of around 4,000 characters, which was 120 segments, and did manual LQA sentence by sentence to check if there's any error in terminology, accuracy, style, audience appropriateness, and locale conventions. And it turned out that most errors occur in terminology, and we checked that are mostly the short phrases, especially those like abbreviation Chinese, which was maybe around just the 3 or 4 characters, but should be explained in very long sentences in English, and that's what Microsoft failed. But the overall quality score was 91, which just passed our quality threshold value. And later we compared the time cost of between MTP and the human translation. So the valid time spent on MTP usually includes machine training, models comparison, LQA, and post-editing. As to our project of the latest work report 2022, the valid time of MTP roughly accounts for first the machine training, which is 5 rounds by 4 hours per round, and it made 20 hours. The LQA and model comparison cost us 2 hours, and the post-editing of 4,000 characters, which was around 2,600 words, took us around 8 hours by average. And in total, the MTP cost around 30 hours. While we calculated that the human translation may require around 20 hours, which was around 20 hours, but excluding native editing and final I, which will be conducted in normal human translation projects. So the first try of machine training model may cost more time than human translation, but we guess that once a satisfactory model is made and or published, it would save lots of time for our linguists, like term check or parallel text sourcing and learning. But anyway, the native editing and the final I procedures are always necessary for governmental pieces. And now I'm gonna analyze all our rounds of Microsoft models. So we first choose our testing data to be the Government Work Report 2022, which was the latest one. And at first, we thought that the tuning data would impact heavily on the BLUE score results. So we put the leadership discourses of the very early years, like 2013 to 15, into the training dataset. And the most recent, second recent work report of 2021 into the tuning data with no dictionary. However, the result was unsatisfactory and was only around like 18.9, which was much lower, even lower than the baseline BLUE. Therefore, in the second round, we put more recent data into the training dataset that were the 2016 to 18 discourses, and we added a 2020 work report into the tuning dataset. The BLUE score was a little bit higher to 1962, but was still lower than the baseline BLUE. And we guessed about the weight of tuning might impact too heavily on MT output. So we launched a parallel test around 1.5 to verify our guess. And in round 1.5, we transferred all the tuning data into training, just like the Sysran system, but with all the training data unchanged. So the resulting BLUE was astonishingly high, and even ranked the second in all our rounds. It reached 23.31. So given that in the next few rounds, we did not put any data into tuning dataset, but only changed the configuration of the training dataset. And the resulting BLUE scores were relatively low, but reached a final average of around 22, which was higher than the baseline BLUE. And in round 4, we for the first time added a dictionary of like Chinese political keywords list, and that round turned out to be the highest BLUE score of 25.21. We guess it might be due to the accuracy of the trained term base. And next, Haoyang will be discussing about the Sysran system.
So thank you, Reggie. Thank you, Elena, for talking about the training process for Microsoft Translator model. And now I'll talk about the training process of Systrain. Well, for Systrain, we have 3 steps to take. The first step is to clean and prepare the TMX to be used in the translation training. And secondly, testing the generic models that is provided by Systrain. And that is a unique step here for the Systrain training process. And the step 3 is training the model. Now let's jump right into it. For training model on Systrain, we have a unique step to take in, that is the generic model evaluation result, because it doesn't like the MS translator that whenever you train a new model, it will show the generic model's BLUE score automatically. And here you can see the generic model evaluation result. We run every single model we have on Systrain for the language pair of English and Chinese. And the highest score is scored by the Systrain generic model large, and it scored 19.8 with everything come after that. So we decided to use the large generic model of Systrain as our basis model for the future training. So for the BLUE score of Systrain models, we can see that after the very first round of training, the BLUE score rise right up above 30, and every single round after that only yielded marginal growth. And in all 4 rounds of training, they all went above the baseline, way above. But I believe that across these trainings, the Systrain model, with the current training profile, it has plateaued in the BLUE score. And here you can see the LQA results of the Sysrun model. We evaluate the Sysrun model that yielded 30.8 in the BLEU score, and it gave us a pretty good result with the final scoring at around 96.95. Most of the errors are in the terminology category, accuracy, and style. And apart from that, it has performed really good, and we believe it has met our expectation in terms of the linguistic quality. And now I'm going to hand over to my colleague Elena to talk about our lessons learned.
So we realized as a team there are a couple lessons learned here from this MT training project. The first is that there's actually a significant time cost of MT training. Unlike human translation, MT usually generates output in no time, but the trainer satisfactory model usually takes longer than we actually expected, sometimes even not predictable, because we remember with our Microsoft training, some process took overnight and even longer than overnight. So in fact, there's no need for profit-driven companies to spend much time on refining an MT model to raise its BLEU score. The model is perfect acceptable as long as it reaches an average BLEU score. And second is that there's actually limited help with MT training to help governmental pieces. Machine translation, even the most generic ones, has already provided readable outputs this last decade. There's no grammar mistakes, there's good long sentence break, accurate terminologies, terms and quotes, and a pretty good TMX as well. So we feel like there really is no need to spend much time to develop a system to help with governmental pieces. Because as the data shows, the baseline BLEU score for our project is 21.29, but the average score of the following rounds, no matter how we change the configurations and combinations, stood around 22, with the highest standing at 25. We may conclude that a custom MT model for sure helps save time on parallel text learning, but it provides limited assistance for governmental pieces, since most of the time should always be spent on numerous rounds of native editing, post-editing review, senior linguist rewriting to meet the publishing standards. Yeah, in addition, we realized that when it comes to choosing training datasets, it is important to evaluate if there are enough available and existing datasets that are readily available. This is because the MT engines usually require a large volume of datasets in order to get a system, an engine with a good BLEU score with a good quality. And we also think that the evaluation of datasets should follow a more standardized approach, which mean aligned meta characteristics, whether it's written or spoken, formal versus casual, depending on various locales, and amount of transcreation, and etc. Between datasets and the MT engine to be trained. And last, we realized that as we use two different MT training engines, Sysrun and Microsoft Custom Translator, we realized as a team that Microsoft has a nicer interface and is more user-friendly when it comes to accessibility, integration, sharing between work and colleagues, and visibility as well.
Thank you, Elena, for talking about the lessons learned in our project. Now I'll present to you our final deliverables. So for the final proposed solution, we do propose the use of a trained Sysrun model to be used in future projects. On the other hand, however, I believe both engines have plateaued in BLEU score with the current training profile. You can see that MS Translator has plateaued around 22 to 25, while Sysrun has plateaued at around 30 in BLEU score. Well, for the future training, if we want to make any more progress, other combinations of datasets should be adopted in order to yield a better BLEU score or LQA score.